Okay, this class we will do the OSPF special area experiment. So first is introduction, and the background is the client utilize the OSPF on the network to meet service requirements. So the network administrator intends to convert area 2 into a special area. So for the special area, we have introduced the step area and the unnecessary A area, right? So for the purpose, first we have to do the basic configuration, and then we have to do the OSPF configuration. And the last, we will do the special area configuration. So for this lab, the purpose is the two master OSPF area tab. First is backbone. So the backbone's area ID is 0, right? And the second is standard. And we can use the area ID like the 1, 2, 3, 4, okay, except the 0. And the step area, totally step area, and the unnecessary area, of course, includes the totally unnecessary area. So this is the first purpose. And second, to verify the conditions and behavior of areas in each area. So here we can use the command like show IPOSPF database to see the RSA information on our router. So of course, we can use some command checks the results like the show IP OSPF neighbor to see the neighbor relationship. Of course, we can use the commands like show IP root OSPF to see the routing tables. Okay, so for the topology, we first introduce the topology. Here is our spatial area topology. Here we have 3 areas, right? First is area 0, and this is area 1, and this is area 2. And the area 0 is the backbone. So the R1, R2 device belongs to the area 0, right? And the R1 and R3 belongs to the area 1. For the R2 and R4 belongs to the area 2, okay? So every device, we have to create the loopback interface. So for example, here is R1. We create the loopback 0, and the IP address is 1.1.1.1. The net mask is 32, okay? So other loopback interface is same, okay? It's the same format. So for this topology, we can see the physical interface. For example, the R1 device, this is the gigabit 0, right? And we will configure the IP address is the 12.1.1.1 on the R1, okay? And then we will configure the IP address on the R2. So the gigabit 0, we will configure the 12.1.1.2. So for the 2 interface, the net mask is 24. Okay, so this is the basic configuration is the IP address. So here we can see the requirements for this topology. And first is the device RX, like the R1, R2, R3, R4, right? It's configured with a loopback interface. So here we have introduced it. The net mask is 32, okay, the net mask is 32. And is interconnected with the RY through the addresses sy.1.1.x and the net mask 24. So for this IP address, we also see the examples here, okay. And these addresses are advertised into OSPF, so we have used the network command. So the topology shows addresses of areas. Okay. So for the second, in area 1, and the R3 has a static router configured to port into non-zero using the IP route. So the IP route is the 169.36.79.0, and the net mask is 24. Okay, and this command used to create the static router. So for this static router, we have to set the matrix tab is 1. Okay, so it's redistributed into the OSPF process. And then the OSPF will generate tab 4 and tab 5 RSA. Okay, so this is the second requirement. So for the three requirements is the area 2. For this area, we have said this area we will set become the special area, right? To set this area become the step and totally step NSSA and totally NSSA area. Okay. So for this area, the routing table of other areas, the OE2 or OE1 and ON2 or ON1 behaviors metrics and the LSAs are checked. We have to check the differences between the special area and the standard area. Okay, so we will use some comments and check the results. So the last requirement is to test the behavior of type 7 and type 5 LSAs. Okay, and one area is an SSA area. So if we set the area to become the SS area or totally an SS area, and we can see the type 7 and the type 5 RSA information. Okay, so the external router is redistributed on R4 using the command is the IP route and 173.16 dot and 6 and 79.25. The net mask is 24. Okay, so this command is for the redistributed to redistributed the routers. Okay. So for these requirements, we can see the configuration plane. So first, of course, is the basic configuration, right? The basic configuration is the IP address, like the low-back IP address and the physical IP address. Okay, so after this, we will do the basic OSPF configuration, like to enable the OSPF process, set the process ID, and set the root ID and network, right? This is the second plane. So after this, we will to complete the static routing and redistribution configuration. Okay, so here we will create the static routing on R3 and R4. Okay, and then switch the area to tab. So from the step area to totally step area and to the NSSA area and to the totally NSSA area. So this is our configuration plane. Okay. So after this, and we will see the procedure for this lab. Okay. So first is complete the basic configuration for interconnection IP and low back interface addresses. So here we will do the topology on our environment. Okay. So here we will create the new project. Okay, first we add the router devices. Okay. and add a link. And set the area. Okay, set the area. And add a note, okay, to note the area ID, note the IP address. This is the backbone area. So it's area 0. And this is area 1. And this is area 2. Okay. So for the loopback IP address, we have no, this is 1.1.1, and this is 2.2.2.2. This is 3.3.3.3, right? And this is 4.4.4. Okay, and the loopback IP address net mask is 24. Okay, is a 24. And the physical IP address actually is 12.1.1.1.0, and the net mask 24. And here is 13.1.1.0. Okay, the net mask is also 24. And for this segment, we use the 24.1.1.0. The net mask is 24. Okay, so this is the IP address, and we store all the devices. Okay. Okay, now we will do the configuration. First, we know is the basic configuration, right? It's a basic configuration. So we have to first create the loopback IP address, create the loopback interface and set the IP address, right? And for the physical interface, we have to configure the IP address, right? So for each router, it's the same action, right? And now we will configure. Okay, so first device is R1. Okay, for managing this device easily, and we suggest you can change the host name so that you can find this device easily. Okay, R1. Okay, and now we will create the loopback and then set the loopback IP address is 111 and the uh, netmask is 32. Of course, you can use this way to configure, right? It's the same. Okay, after this, and ending to the gigabit 0, and set the IP address is 12.1.1.1, right? And the net mask is 24. Of course, you can use the 255.255 and dot 255 0. This way is the same. Okay. And after this, configure the IP address of gigabit 1. Okay. And set the IP address is 13.1.1.1, and the net mask of 24 is the same. So after this, we will configure the R2. Okay, and enable and modify the host name so that you can find this device easily. R2. Okay, and after this, first to create the loopback and set the IP as a G.2. This IP will become the root ID of R2, right? And the master net mask is the 32. And adding to the gigabit 0 and set the IP address is the 12.1.1.2. Okay, the net mask is 24. And after this, and into the gigabit 1 and set the IP address is 24.1.1.2. Okay, the net mask is 24. Okay, after this, we will configure the R3. And first, modify the host name. And then create the loopback IP address. And then into the gigabit 1. Set the IP address is 13.1.1.3 and the net mask is 24. Okay, so after this, we will configure the R4. So modify the host name is R4. And after this, create the loopback IP address. The IP address is 4.4. Net mask is 32. And adding to the gigabit 1 and set the IP is 24.1.1.4 and the net mask 24. Okay, so this is our basic configuration for IP address. And after we finished all the basic configuration on all the routers, we suggest you can do the ping test to verify the directly connection. Okay, so you can ping the R3 and R2 on R1. So here we can log on the R1 and ping the R2 and ping R3. Okay, ping 13.1.1.3. So the direct connection is okay, right? Between the R1 and R3. And we will ping the R2. So it's 12.1.2. So the net, the directly connection is okay. Okay. So next we will test the connection between the R2 and R4. And ping 24.1.1.2. Okay, so this means the connection between the R2 and the R4 is okay. So after the pin test, we will do the second part. So this is the first part we have finished. And for the second part is to complete the OSPF basic configuration. And we will see the configuration here is the root OSPF1 and then do the network. So here you can add the root ID. Okay, you can add the root ID. So like the root OSPF1, this is the process ID. And then at the comment is the root ID 111. Okay, and after this, we can use a network and to do the announcement. So for the R1, R2, R3, R4, every router, we have to do the OSPF basic configuration. So let's go on. So for the one device is the R1. So maybe sometimes you will meet the question like you forget the IP address or you forget your IP address configuration. Maybe you have many interfaces on your device, right? And you can use the show IP interface brief to see all the IP address configuration on your router so that you can find which IP address you want to do the network. Of course, you can see the IP address configuration is correct or incorrect. Okay. So first we have ending to the root OSPF configuration model. So first create the root OSPF and set the process ID is 1. And after this, we can configure the root ID like the root ID 111, okay, and set the root ID. After this, to do the network, and for the R1, we have 3 interfaces to do the network, right? And then is the loopback IP address. So it's network 101.1 and 0.0.0, and we will network this to the area 0. Okay. After this, we network the 12.1.1.0. Okay. And for this, we will network to area 0. It's the same. And next, network 13.1.1.0 and 0.0.0.255 for this, and we network to the area 1. Okay. So here is our topology. So this interface actually is in the area 1, right? So gigabit 1. For the gigabit 1, the IP address is the 13, right? So we do the network 13, this segment to the area 1. Okay, after this, maybe we can start the configuration. Okay, next device is the R2 device. And first, we have to enter into the OSPF configuration mode and set the configuration process ID. And then the network ID, 2.2, okay. And then we can show the IP interface brief to see the IP address configuration and then do the network. So it's a network 2.2 and then choose the area 0 and network the 12.1.1.0 And then this will be networked to the area 2, area 0. Okay. And next is the network 24 and 1.1.0. Okay. This will network to the area 2. So after this, we will do the OSPF configuration and then start the configuration. This is R2, and the next is R3. It's the same action, right? And set the root ID and then network. We can show the address configuration. Okay. This is the area 1, right? This is area 1. And for the physical address, also is area 1. Okay, and R4. And create the OSPF process, set the process ID is 1 and set the root ID. And after this, we save the address configuration and do the network. It's a folder 4 and sets the area ID is area 2, right? Okay, and the network, the 24, 1.1.0 and 255 and the area 2. Okay, after this, we can start the configuration. For this, we also can do the start action. Okay, all the basic configuration we have finished. So here we can see our OSPF basic configuration. Okay, after this, we have to do the static routing and the redistribution configurations. So here, we have two routers. We can see here is R3 and R4. First, we have to do the IP route and set the routing information. Okay, this is R3, and then we add into the OSPF1 to do the redistribute. So here is the root OSPF1 and the redistribute the static. This static routing table is this. Okay, this, and for the metric tab is for 1. Okay, so we will see the this routing in our routing table and say the metric tab is the 1. Okay, and next is R4. For the R4, here we can see we create the IP route. Okay, this IP router also have to be distributed to the OSPF. So here we will adding to the OSPF configuration model and then do the redistribute option, do the redistribute action. Okay. So here, and first we have to do uh, the routing table. Okay, and on R3 create the IP route. Of course, after this we can check the results and we can use the show IP route. Okay, and we can see this router. So it means we have finished the creates the static route. And after this, we have to do the redistribute. So we add into the router OSPF 1 and do the redistribute static. So which which route entry we have created just now. Okay. So for the metric tab, we set the 1, and here we can see we have 1 and 2 options, right? And here we set this route entries to be the 1, okay, and the subnets. So this is the R3 configuration. And for R4, we also have to create the static routing entry. And the first is the IP route. Non-zero. Okay, so here we will do the redistribute route OSPF1 and do the redistribute this static routing entry to the OSPF. So after this, we have finished this step, right? So here we can see when area is a stand area, each area learns the routes from one another and has identical routing entries. So as shown in the following entries. So here we use the show IP router on R1, R2, and R3 and R4 to check every router's routing table, right? So this is a standard area. And first, we can check the routing table on R1. Use the show IP router. Okay, maybe you can add the OSPF. So here we can see the routing tables has the O and the OIA and the OE1 and the OE2. Okay, and this is redistribute to the OSPF and generate to the routing entry, right? Okay, and the others is learn from other neighbors. So this is the route, and we also can do the show IP route OSPF on R3 and R4. So every router we will do this action. So of course, show IP route OSPF. Okay, we will see the routing table, and after this, we will check the routing table on R3. Show IP route. It's the same action. Okay. If you want to see the OSPF routing table, you can add the OSPF. Okay. If you don't add the OSPF, you will see all the router routing table on our routers. So next is R4. Show IP route. Okay, it's the same. And we will see the S. So the S is means the static. So means the static routing entry. So if you don't want to see the static, and you can use the show IP route OSPF, and you won't see the S. Okay, you won't see the S. After this, we will to check the RSA behaviors, okay, and we will use the show IP OSPF database, this command, on every router. Here we can see every router has the RSA information by this command. So from the R1, okay, show IP OSPF database. and we can see the root link states, network link states, summary link states, ASVR summary link states, router link states, network link states. Okay, so the AS external link states. So we can see the level 1, level 2, level 3, level 4, level 5 RSA information, right? And then the same action on the R2 show IP OSPF database. And you can see all the RSA information. And for the R3, show IP OSPF database. Yeah, we also can see the RSA information. For the R4, show IP OSPF database. Okay, so this is check the RSA information comment. So after this, we will do the special area action. First, we will configure the area to become the step area. This is the first special area. Okay. So here we can see we will do the action on R2 device and R4 device. So we know the step configuration have two sets on the R2 and R4. So we can see the topology is R2 and R4, right? And we want to set this area to become the special area. So we have to set the R2 and the R4 to be the step area. Okay. And into the OSPF process. And then to set this area become the step area, the command is area 2 step. So now we can see some tips on our router. Okay, so we have to do the same action on R4. And router OSPF 1 and do the area 2 step. So after we enter this comment, we can see the tips on our device, right? So this is means we the neighbor relationship again, right? This is disconnected, and it means the options mismatch, right? Okay, because the R2 configure the step flag, but R4 haven't configured this. So when we configure the area 2 step, this comment on the R4, it means R4 becomes the step area. So the R4 will build the neighbor relationship with the R2 again. So here we can see the state from the load to 4. Okay, and we check the neighbor relationship to OSPF neighbors. And we can see the state is 4, right? So this is the step area. So here, when area 2 is the step area, the routing table does not contain a router for the static routing entry in area 1 and 0, okay, and no router for the 169.36.79.0 in area 2. This is because step area cannot redistribute or receive external routes, but a default route to area 0 is included in area 2. So we also can see the routing entries So here we will see the routine entries is on R1 and the R2. Here is R3 is okay. But here we can see we have the static is 0.0.0.0. Okay, the net mass is 0. For this new routine entry will happens on the R4. Okay, and we can check it. R1 show IP router OSPF. Okay, and check it on R3. Okay, we also can see the detailed routing entry, right? And then check it on the R4. So we can see there is OIA, and this is 0.0.0.0. This new routing entry here on R4. Okay. So this is the step area. Okay, when area 2 is the step area, so area 1 and 0 has RSA 1 and 2, 3, 4, 5. So we can see the 5 types RSA information, but where the step area lacks the RSA 4 and the 5. So here we can see the RSA behaviors on every router. Here we can see the R1, okay, and this is the R2, right? We have the link states and the network link states and summary link states, ASBR summary link states, and the router link states. So this is R3, it's the same, right? Every RSA information we have. And then we will see the R4, okay, R4 database, and we just can see the root link state and network link states and summary link states. So here we can see it's on our environment. So we just see 2 routers here, show IP OSPF database. So here we can see the root link states, network link states. This is the level RSA 1 and the RSA 2, RSA 3, right? And this is the RSA 4, right? And the external is the RSA 5, right? So we can see the RSA information on R1, R2, R3. So now we go to the R4 and show IP OSPF database. So here we just can see the router link states and network link states, summary link states, right? And we just can see the root link states for 2.2 and 4.4, and see the network link states is 24. So this is the directly connection between the R2 and R4, right? And we can't see other segments like this segment or this segment, right? And for the summary link state, we can see the 0000, right? This link state. And the 1.1.1, 2.2, 3.3.3, and 12.1.1.0, and 13.1.1.0. Okay, this is the summary link state information. But compare with the R1, we can't see the RSA 4 and the RSA 5, right? So this is the step area. And after this, we will configure the area 2 to become the totally step. So for the totally step configuration is also we have to do the action on R2 and R4. So we will see the commands is the area 2 and step no summary. So if we want to configure one area to become the totally area, we just to add the no summary. Okay. Here we do the configuration on our routers. So it's R2. Okay. And this is area 2. And we set this is the step, right? And now we want to configure this area to become the play step area. So we add the no summary. Okay, we add the no summary. So this is the totally step area. And then for R4 interface, for R4 routers, okay, after this, we have finished the totally step area. Okay, and when area 2 is the totally step area, the routing tables does not contain a route for this static in area 1 and 0, and no router for this static information in area 2. And this is because a totally step area cannot redistribute or receive external routes. So, but the default routes to area 0 is included in area 2. Okay, so we can see the default route on R4. Okay, we can see this show IP route OSPF. Okay, we can see just one routing entry here is a 0.0.0.0. Okay, so after this, the totally step area does not receive the inter-area routes, so there are no detailed info routing entries from other area on R4. We just can see the RSA information belongs to own area. So other area we can't see any RSA information. Okay, and we can see the R1 routing entry. Here is R2 routing entry. This is R3 routing entry. Okay, but for R4, we just can see the 0.0.0 for different area. Okay, and the other routing information is their own area. Okay, and after this, we can check the RSA behaviors. So here, when area 2 is totally step area, area 1 and 0 have RSA 1 to 5, and where the totally step area has no areas 4 and 5, so we can see the OSPF database. So here is the R1 database. This is a R2 database, and this is R3 database. We can see the root link states, network link states, summer link states, AS external link states, right? It's the level 1, level 2, level 3, level 4. And for the R4, okay, we can see the routing tables here. And we also can see the RSA information, use the show IP OSPF database. So it's very simple for this device. Okay, we just can see the root link states just for own area. Okay, so for other area, we can't see the detailed information. And next, we will set the area 2 to become the SSA area. So first, we have to do the action on R2 and R4. So first, we have to do the no area 2 step to disable this area to become the step. And after this, we will configure this area become the SSA. Okay. And then we will go on to the R2 and no area 2 step. Okay. And for this, we have to go to the R4 and then into the router OSPF 1 and no area 2 step. Okay. And then set the area 2 becomes the NSSA. Okay. And the area 2 NSSA. So this is the command. And of course, for this command, we have to do the same action on root 4. So area 2 and the SSA. Okay. And then to check the OSPF neighbor relationship. Okay. So it's init. And wait a moment. Okay. So now the state is become 4, right? It's become 4. So show IP OSPF neighbor. And we can see the state is okay. So we have finished the NSSA area configuration. So when area 2 is an NSSA area, the routing tables contains a root for the 172.16.79.25 in area 1 and 0, and no roots for 169.36.79.0 in area 2. This is because an SSA area can retribute but does not receive external routes, and a default route determined for area 0 cannot be included in area 2. So we also have to check the routing entries and check the OSPF database. Okay. So we can see the results here. And after we analyze the results, we will do the action on our environment. So we can see the R1 and R2 and R3. They have the same routing entries, right? And for R4, we can see the show IP routes, and for the area 2, because this area is an SSA area, so area 1 and 0 have the RSA information 1 to 5, right? But for the NSSA area, the NSSA area will generate the new tab is a RSA 7, okay, it's a RSA 7, but has no RSA 4 and 5. So now we can check the routing tables first. Show IP route, okay, and you can add the show IP route OSPF. It's the same. And R4 show IP route OSPF. And you will see the 1, 2, 3, okay. And you also can check the routing tables on R2. Show IP route OSPF, right? It's the same. And then show IP route OSPF. Okay. So after this, you can check the database on R1 and R2 and R3 and R4. So you can see, we can see the router link states, network link states, summary link states, ASBR summary link states, and the AS external link states on R3, right? But for the R4, we can see the root link states. It contains the 2.2.2 and 4.4.4, but it not contain the 1.1.1 and the 3.3.3.3, right? And we can see the network link states. We also can see the summary link states, but we can't see the ASBR summary link states and the AS external link states. Here we can see the database, right? Okay, after this, we can see the new RSA tab. This is the NSSA external link states. So this is a RSA 7, right? And we can see the new RSA information here, but we can't see the RSA 4 and RSA 5. So we back to our environment and see the R3 database, show IP OSPF database. So we can see, right? We can see. And for R4, we go to the R4. Show IP OSPF database. And we can see the R1, the level 1 and the RSA 2, RSA 3, and RSA 7, but no RSA 4 and the RSA 5, right? Okay, after this, we will do the last area configuration. It's totally in SSA. So we have to add the no summary. This command to the R2 and R4. Okay, so here we go to the R2. And router OSPF 1 sets the area 2. It's an SSA, right? And adds the no summary. Okay, this is a totally an SSA configuration comment. And go to the R4 is a router OSPF 1 and area 2 an SSA no summary. Okay, so this is an SSA totally an SSA configuration, and for area 2 is a totally an SSA area. So the routing tables contains a router for 172.16.79.25 in area 1 and 0, and no route for 169.36.79.0 in area 2. Okay, we can't see the detailed routing tables or routing entries in area 2. Okay, so we can see the routing table on R4 to IP route OSPF. Okay, we just can see the OIA has 0.0.0.0. We can't see the detailed routing entry. So we can see the detailed routing entry on the R3, R1, and R2, but we can't see the detailed routing entry on R4, right? This is the differences between two routers. Okay. So we can do the same action on R1 and R2 and R3 and R4, right? And after this, we can check the RSA information on every routers. So here we configure this area to become the totally SSA. So area 2 is a totally SSA area. So area 1 and 0 has RSA 125, where the totally NSSA area has a RSA 7. So it means the area 0, the area 1 don't have the RSA 7, right? But for area 2 has the RSA 7. But like the RSA 4 and 5, it means the area 0 and area 1 has the RSA 1, 2, 5. But for the area 2, we don't have the area 4 and 5, but we have the RSA 7. Okay, when passing through the R2, so we know the R2 is the ABR device, belongs to the area 0 and the area 2, right? So the RSA 7 will be converted into RSA 5. As RSA 3 only has a 0.0.0.0, and the following RSA behaviors, we use the SHU IP OSPF database. Okay, so we see all the database on every router's SHU IP OSPF database, and we can see the RSA 1, RSA 2, RSA 3, RSA 4. Okay, this is RSA 4, and this is RSA 5. Okay. And for R2, it's the same SHU IP OSPF database. It's the same, right? It's the same. But we can see the new RSA is a RSA 7. It's an NSSA tunnel link states here. Okay, because the R2 is belongs to the area 2 and area 0. So we can see the detailed information about RSA 1 and 2 and 3 and 4 and 5, of course. We also can see the RSA 7 on R2. And for R3, SHU IP OSPF database. So we can see the RSA 1, 2, 3, and 4, and 5, but we can't see the RSA 7, right? And for the R4, SHU IP OSPF database. And we can see the R1, level 1, and the RSA 2, and RSA 3, but we can't see the RSA 4 and the RSA 5. We can see the RSA 7 here, right? So this is the differences between different routers. Okay, so this is the database. This is the database. Okay, all the special configuration we have finished, and some key points we have to introduce. So first is the step area blocks the tab 4 and tab 5 RSA's information. So we can see the tab 4 and tab 5 RSA on R4, right? This on R4, because for this router we have configured. This router becomes the step area, totally step area, and the NSSA area, and totally NSSA area. So we just can see the detailed RSA information belongs to the area 2, but we can't see the detailed RSA information belongs to other area, right? And if we configure the step area will create a tab 3 RSA default route on the ABR route. Okay, and for the totally step area, the totally step area will block the tab 4 and tab 5, and also will block the tab 3. Okay, it's a totally step area. It's the differences between the step area and totally step area. And create a tab 3 RSA default router on the ABR router. So we can see the SHU IP router OSPF, see this routing entry, right? So the routers in step and totally step area cannot redistribute routers from outside the OSPF domain. Okay. And next is an SSA area blocks the tab 4 and tab 5 RSA information, but does not create a tab 3 RSA default route on the ABR router. So this is the differences between the NSSA area and the step area. Because the step area will create a tab 3 RSA default route, but the NSSA area does not create a tab 3 RSA default route. This is the differences, okay? And for the totally unSSA area, blocks the tab 3, 4, 5 RSA information. And for the totally unSSA area, we'll create a tab 3 RSA default router. So we can see the 0.0.0.0, these routing entries on the R4, right? On the R4. And routers in NSSA and totally NSSA area can redistribute routes from outside the OSPF domain. So this is the differences between the NSSA area and the step area, because the step area cannot redistribute, but we can do the redistribution on NSSA area and generate the RSA7 on our routers. Okay, so this is the key points for this lab.